right? So this vegan set will be this set, right? So I cannot draw it in a circle because I have actually mentioned the elements separately. So this actually represents, imagine this to be representing a circle. It need not be a circle, just an enclosed figure can be a set. So the set C represents all the vegan food, set A represents all the vegetarian food, and set B represents all the meat related food. So you can see that this set C is totally enclosed in the set A, but there is no relation between the set B with set A or set C. So this is another example of Venn diagram. Here I have taken one more example, language proficiency. So if we have a set, or sorry, if we have a universal set which represents all the different languages which is spoken in this, in earth or in this world, so we can have a person who speaks. So suppose we have 7 languages currently: Hindi, sorry, right. So suppose we have a person whose preference is a person A who speaks Hindi and English, and we draw this set A as a person who speaks Hindi and English. Okay. Then we have a set B or a person B whose preferences is Hindi and French. So this Hindi will be in the set of languages which is spoken by the person B, and French will be here. So what this set B represents? It represents the languages which is spoken by this person B. So he speaks Hindi and French. Now we have a person C who only speaks suppose German. So German will be outside this set. So it will be here. So he speaks only German. So in this way we can make a Venn diagram which represents different sets. Suppose a person is there which is D, and he speaks Hindi, English, French, and German, right? So all these 4 languages, Hindi, French, English, and German, all these 4 languages are being spoken by this person D. So this set will be like this, right? So this will be set D. But you have to make sure that this universal set always encloses all the sets. So no matter if it is set A or set B or set C or set D, all the set will be inside this universal set. So this is some of the examples of Venn diagram. We will do one more example on Venn diagram. So suppose we have a set or the universal set which represents sports preferences by different people. So someone can like hockey, someone can like football, someone can like cricket, like that. So similarly, we have a person A which likes hockey and football. We can have a person B which only likes cricket. We can have a person D which likes no sports. So it is an empty set, right? It is an empty set. So empty set, we don't draw it in a circle. So it will have no element, right? This set D will have no element. Suppose a person E which likes hockey and one more kabaddi. So this E represents the person's preferences of sports who likes hockey and kabaddi, right? So this is a universal set U, and these sets here represents different sports preferences. So again, in this case also, this is a Venn diagram representing sports preferences. Now we will see how different operations are performed in sets. So previously we have seen how we represent, how we know what is the notation used for sets, what are the different kinds of sets, what are equal sets. Now we will see how we operate in sets. So what is operations on sets? So operations on sets refer to the way in which sets can be combined or manipulated or created new. So this operations on set can be of different kind. It can be of it can be a union operation, It can be an intersection operation, it can be a complement operation, or it can be a difference operation. So we have to understand what these different operations on set are, right? So first we will understand what is union. So union is a union of two sets, is the set of all elements that belong to either of the two sets. So what does this mean? Suppose you have two sets, set A and set B, with elements as mentioned here. So you see, a union is just the sum of all those elements. I mean, not the sum. It will be a set which contains both the elements of both the sets. So suppose we have to find the union of set A and set B, and this union is denoted by this operator. So we'll write A union B, and it will be a set with all the elements of A as well as the elements of B. So it will contain 2, 4, 6, 8, 10, 12, 14, 16, and 18, right? All the elements of A and B will be in the set. This is also a set, okay? So this is a set which represents the union of set A and set B. Now you can draw a Venn diagram similarly. So if you have set A, it will be 2, 4, 6, 8, 10, and a set B which contains 12, 14, 16, and 18. So a union will include both these sets, this set and this set, right? So it will be another set A union B, and it will contain both these elements, this element as well as this element. Okay. Now suppose we have this example, set A and set B, but here you have to see that the elements which are present in A is also present in B. Like 2 is an element of A as well as in an element of B. So when we calculate, or when we find the set A union B, then this 2 will not be repeated. It will be just one element, 2. Again, we have here 4, but 4 is not here, so we'll just write 4. Then 6 is in this set. 8 is in both the sets. Again, we'll just write 1, 8. Then 10, then 16. Okay. So in this case, you see, there are some common elements, 2 and 8. These are common elements in both the sets, but they are not repeated twice. So what does union do? Union is just the collection of both the elements of the sets. So if we perform a union operation between the set A and set B, so this set, which is the union of set A and set B, will contains all the elements of A as well as the elements of B. But if any element is present in both the set A and B, it won't be repeated twice. It will just be present once. Like this set, this element 2 and the element 8. Okay. So this is union operation. We'll see one more example here. So again, you have to see how this Venn diagram is created for union operation. So if we see this example where A has these elements and B has these elements, so we can draw the elements of the using Venn diagram. So A is this, which will contain 2, 8, 4, 6, and 10, right? 6 elements, right? And this is set A. Now you see B has these two elements, 2 and 8. So these two elements will be in B as well. Okay, 2 and 8. Now the extra elements of B are 10 and 16. So you see this circle represents the set B, and it has the element 2, 8, 10, and 16. And this 2 and 8 is present in both the set. Okay. So these are the common elements of both the sets. And what is union representing? Union representing all these elements. So this elements of A as well as the elements of B. So this is a union operation. So what does union say? The region which is comprised of A as well as comprised of B. The overall this region here is the union operation between the sets represented in Venn diagram form. Okay. So union of the sets follow some properties. What is the property? It says that A union B is same as B union A, and this property or law is known as commutative property. So you can take two examples and see what this says. So suppose you have a set A which contains 1 and 2 and a set B which contains 4 and 5. Okay. And we are performing this operation A union B. So when we perform the operation A union B, so we will get 1, 2 from the set A, then 4 and 5 from the set B. Okay. Now we'll do this operation B union A. Sorry, this will not be there. B union A. So we will do first 4 and 5 from the set B, then 1 and 2 from the set A. Now you see the elements of A union B and the elements of B union A are the same. So 1 is here and here, 2 is also here and here, 4 is also there, 5 is also there. So this law just says if you perform A union B, it will same as if you perform B union A. Now what does this associative law says? Associative law says that if you have performed A union B and then in this set you perform union C, then this entire set which will you get after these operations A union B union C will be same as if you perform B union C first and then you perform A. So it doesn't matter in which order you perform union operation, the set will be the same. So you can see here also. So if you have an element C, sorry, a set C which contains the element 10 and 12. So we will perform this operation first, A union B. So we have done A union B. To this we will union C. So we will get a set A union B union C, right? So this is the set A union B and we will perform this union of this set and this set. So it will contain 1, 2, 4, 5, 10 and 12, right? Now this right hand side of the expression says you have to perform B union C first. So B union C will contain the elements 4, 5, 10 and 12. Sorry, 12. Now to this you have to union A. So now you will get A union B union C. So this is the set B union C. To this you have the set A and you have to perform this union operation. So it will contain the elements of A which is 1, 2 and the elements of B union C which is 4, 5, 10 and 12. Now if you notice this set and this set is the same. So 1, 2, 4, 5, 10, 12. This also contains 1, 2, 4, 5, 10, 12. So associative law holds. Now if you do A union phi, where phi is denotes an empty set, then you will get A. This law is known as the law of identity element. So this set phi contains no element. And when you do union of set A and this no element set, then obviously you will get a set which is just the same as the set A. Okay. Let me erase it and then we'll proceed forward. Now you have one set A and you are operating it with itself. So union operation has been performed in the set itself. So you see if there is a set which contains some elements, suppose it contains A, E, I, O, U, the vowels in the English alphabet, and you are performing a union operation between itself. So set A union set A. So you take two sets which is same A, E, I, O, U. Now if you perform union, what it does it does contains the element of both the sets, but here the sets are same. So this union operation will give none other but the same set which is the set A. Okay, this is known as the idempotent property. Now this is U. Here U represents the universal set. So universal set contains all the possible sets, right? Now if you have a set A, so the set A will be a subset of U, right? Set A, because universal set contains the set A, it will contain more sets which is not A. Now if you perform an operation of union of the universal set, sorry, just 1 minute. Now if you perform the union of the universal set U and the set A, you will get the universal set because this universal set contains the elements of A. So this law is known as law of universal set U. This is the second operation which we are going to see. It is known as the intersection operation. So what intersection operation does is, the intersection of two sets is the set of all the elements that belong to both the sets. So the element which we will get after intersection of, suppose we have two sets A and B. So we'll write this intersection as inverted U. So this is an intersection operator. So the intersection of two sets gives a set which contains the elements which belong to both the sets. The element which we'll get here must belong to both A and set B. So here is one example. We have two set A and set B. We have to see what are the common elements of both set A and set B. So you see 2 is here and also here. 4 is here, but it is not here. 6 is here, but it is not here. 8 is here, but it is also here. So these are common elements. 10 is here and 10 is also here. So these elements are common, 2, 8 and 10. So when we perform A intersection B, we will get the set, the set 2, 8, 10. So these are the common elements of A and B. So we will get only 3 elements in this set, A intersection B. Okay. Now, see this example. You have a set 2, 4, 6, 8, 10, and B has the elements 12, 14, 16, and 18. If you notice, there are no common elements between these sets. So none of the elements present in this set are present in the set B. So if we perform the operation intersection A intersection B, if we perform the operation A intersection B, then there will be no set. It will be an empty set. So how do we write empty set? We can write it in a curly braces which has no element, or we can write phi, right? Now you notice, what is union doing? Union gets the sum of, not sum, it gets the set of all the elements which are present in both the sets, right? And intersection does is, it only contains the element which is in both the sets. So if we draw a Venn diagram of this example, so the set A will have 2, 8, 10, 4, and 6, and the set B will have 2, 8, 10, and 16. So you see this 2, 8, 10 is present in A as well as in B. So in Venn diagram, this region, which is the overlapping between the circles of set A and set B, represents the intersection of both the sets, right? You can see here also, the elements are 2, 8, and 10. So this region here, this region represents intersection. Now, if I ask you, what is the union? So union is this region. Let me change the color to a good color, which you can see. So we have seen this is the intersection. So what will be the union? Union will contain all the elements which are present in both the sets. This region will be union. Okay. So union of A and B will contain all the elements which are present in A as well as in B. So this is the representation when we have union and intersection in the Venn diagram form. So Venn diagram will consider the common between common or intersection of both the circles, and this union will contain all the elements in both the set A and the set B. Now moving on to the next slide. So we will see some of the properties of intersection. Okay, I guess some of the properties which I have written has been erased, so I can write it here. So suppose we have intersection operation between the set A and set B, A intersection B. Now, if we perform A intersection B, it will be same as the operation of B intersection A. Okay, this is known as the commutative property of intersection. Just let me check. Yes, commutative property of the intersection. So you can see here also. So in this example, we had A intersection B as the set of elements 2, 8, 10, right? Because 2 is present in both the sets, 10 is present in both the sets, and 8 is present in both the sets. Now, if you perform B intersection A, it will be same because the common elements will remain the same. So 2, 8, and 10. So this property says that A intersection B is same as B intersection A. Okay. Now, the second property is, or the second law is, if you do A intersection B intersection C, it will be same as A intersection B intersection C. Okay. So if you can take two examples and see if this property holds. And I can also show you, but this property was also true in the case of union. So if you see in this example, which is the associative law, this is same, only in that case we were doing union, here we are doing intersection. Now if we do intersection of A with an empty set, you will get an empty set, because empty set contains no elements and set A has some elements. But what is the common element between the set A and empty set? There is no element which is common in the set empty set and the set A. Therefore, you will get this empty set. Moreover, if you do an intersection of the set A and the universal set U, so if you do an intersection of the set A and universal set U, see, universal set U contains the set A, because universal set, which we represent in the Venn diagram using a rectangle, contains all possible sets with respect to this context. So it contains the set A, it contains the set B, it contains the set C. So all the sets which are there will be contained in this universal set. Now you are doing intersection. So intersection says, what intersection does? It gives the element which is common to both set A and set A and universal set. So this whole set A will be the intersection. So if you do this intersection, you will get the set A. Okay. Now the last property is distributive property. It says that if you have set A intersection B union C, it will be same as A intersection B union A intersection C. You can see this very clearly when you do. You can see this very clearly with a Venn diagram. So let me erase this and I'll show you how we can understand this using Venn diagram. So suppose we have three sets. Set A, I'm not drawing very good circles, by the way. Set B and set C. Okay. So in this side, the left hand side of this expression says that we have to do B union C. So what is the region of B union C? B union C will be this region. Right? This region will be B union C. Now it is doing A intersection B union C. So A intersection B union C. So intersection is saying that the elements which are there in A and the set B union C. So whichever the overlapping region is will be the intersection. So this will be the intersection region, right? Right? A intersection B union C. B union C was this region, and intersection was the common between B union C and the set A. Now, if I draw another diagram with these three circles, set A, set B, and set C, so you can see it clearly. So we will do first A union A intersection B. So what is A intersection B? A intersection B is only this region, right? And the next thing is A intersection C. So what is A intersection C? This region, A intersection C. Now it is saying you have to do the union of A A intersection B and the A intersection C. So this region will be the union of both the sets, right? The elements which are there in both the sets A union B and A union C, this and this. So you see the region which we get here and here in both the diagram, Venn diagram is the same. So this expression is same as this expression, or the set which is obtained from this expression is same as the set which is obtained is this expression. So this is a law which is known as the distributive law, and we have seen it clearly using Venn diagram. Okay, I hope you don't have any questions here. You can ask your questions. Okay, so I'm moving forward. So the next operation which we perform in set is known as the difference operation. So this is a little bit tricky. What is difference operation? First I'll read out. So the difference between two sets is the set of all that elements that belong to the first set but not the second set. And we represent it by minus sign or a backslash. So it is written as A minus B or A backslash B. And we call it as A minus B or A difference B. So this expression is called as A difference B, and this expression is called as A minus B. And both these represents the same thing. What we are doing, we are subtracting one element. It is not a very technical term. I'm just using this term to explain you. We are just eliminating the elements which are there in A, which are there in B from A. So here is one example. So we can take this example first. So we have a set which contains 2, 4, 6, 8, and 10, and a set B which contains 2, 8, 10, and 16. So this set A, we have to do A minus B or A difference B. So from the set A, we have to remove the elements which are present in B. You can read it again. It says that it is the set of all the elements that belongs to the first set. So what is the first set? The first set is the set A, right? All the elements which belong to the first set but not the second set. So here 2 belongs to the first set, also belongs to the second set. 8 belongs to the first set and also belongs to the second set. 10 belongs to the first set and also the second set. So these elements 2, 8, and 10 will not be there in the set A difference B or A minus B. So we'll write the elements of A which are not in B. So it will contain 4 and 6, right? 4 and 6. We will not write the element 2, 8, and 10 because it is there in the set B. If you see this in a Venn diagram, it will be very clear to you. We have a set A and a set B, okay? And the set A contains elements 2, 4, 6, 8, and 10, okay? And the set B contains 2, 8, 10, and 16. Now we are subtracting this set from this set, and this is not a technical term. I am using this to explain you. So we are removing, let me change the color so that you can see what is happening. We are removing this set from the set A. We are removing it. So we will remove these elements from the set A and we will get A difference B. A difference B. So these elements which is there, I should not do this. Let me erase it. So this region actually is the set which is A minus B, which will contain two elements 4, 6. Okay. So now if you take this example A and B, you see we have to get A minus B. Now, there is no common element between A and B, right? So you will write the set A, 4, 8, 6, 2, 4, 8, 6, 8, and 10. And B doesn't contain any element of A. So this set will be same as the set A in this case. Okay. Now, one thing to note here is A difference B is not the same as B difference A, or A minus B is not the same as B minus A. Let us see how this is the case. So we will erase this to get some more space. See, when we did A minus B, we get this set 4, 6. Now we will do in this example B minus A. So when we do B minus A, we have to write the elements of B and remove the elements which is common to both. Again, read the definition. It says that the set of all the elements that belong to the first set. So here first set is the set B and not in the second set. So we will write the elements. Can we write 2 here? No, we cannot write 2 here because 2 is in the set A. So 2 will not be in this set. Can we write 8 here? No, we cannot write 8 here because it is there in the set. Sorry, this one. It is there in the set A. So 8 will also not be there. 10 will also not be there. So it will only contain 16 because 16 is not in the set A. So you see B minus A only contains one element which is 16. So this will not be there, only 16. But A minus B contains two elements which is 4 and 6. So A minus B is not the same as B minus A. Okay. In the earlier case, when we were doing A union B, so this was same as B union A. Remember? We can go back and see here. Here we can write, see, A union B was same as B union A. Similarly, when we are doing intersection, we wrote that A intersection B was same as B intersection A, right? But in this case, when we are doing the difference of two sets, this or this, we cannot say. It may be a case in some example, it may happen that B minus A is same as A minus B, but generally it is not true. So there is no law that can say that this is true because this is not true. Okay. So A minus B will not be same as B minus A. You can see this in Venn diagram also. So if you draw two sets A and B, so suppose two sets are there, set A and set B with some overlap. So A minus B will be this area, but B minus A will be this area, right? I can make you explain once more how I'm drawing this. So see, A is this set, and when you're doing A minus B, you're removing the elements of B. So these elements, which is common to both, is as elements in B. So you will remove the elements from A and you will get A minus B. So in this case, this will be the region which is A minus B. Now, if you do B minus A, so this is the set B, right? This is the set B. And you are removing the elements which are common to both. So again, you are removing this region, right? You are removing this region. So you will get this region you will get. So these sets A minus B and B minus A are different sets. Okay, these are not the same. Now, very important thing to notice, A minus B, A intersection B and B minus A are mutually disjoint. So I don't think you know what is disjoint sets. If you know, but also I'll explain it here once more time. So disjoint sets are the sets which have no common element. So suppose we have a set X and a set Y. It will be disjoint when there will be no overlap between the sets. What does overlap mean? Overlap means they have common element. For example, X contains 1, 2, 3 and Y contains 4, 5, and 6. Okay. So in this case, 1, 2, and 3 will be there, and 4, 5, and 6 will be there. So there is no element which is common to both the set X and Y. Therefore, X and Y are disjoint sets. When we have two sets M and N, where M is 1, 2, and 3, and N is 3, 4, and 5. So there is one common element, 3, in both the sets. So in this case, when you draw M and N, so one element will be common, 3. And the set M will contain 1, 2, and 3, and the set N will contain 3, 4, and 5. So this is the common region. Therefore, M and N has some common region and they are not disjoint. So two sets are disjoint when they don't have any common element. Now what this note is saying is A minus B, A difference B, sorry, A intersection B and B minus A are disjoint. So I'll erase this and I'll show you how this is true. So I'll draw two sets. So we can take few cases in this case. So let me take few cases. So suppose I have case 1, case 2, and case 3. Suppose we have 3 cases. Okay. So in the first case, set A and set B have no elements in common. In the second case, set A and set B has small region which is common, or few elements are there which is common to both. And in the third case, one set is inside the other set. So suppose set A is bigger and set B is smaller. Now in these 3 cases, we can see how A minus B, A intersection B, and B minus A are represented. So what is A minus B? So it will be, in the first case, it will be the set of the elements of A when we remove the elements of B. But there is no common element between the set A and set B. So this will be the region which is A minus B. Okay. In this case, what will be A minus B? So we have a set A and a set B, and this is the common region. So this will be the region which is A minus B. So we will get this region as A minus B. Right? This region is A minus B. Because this is common, and from the set A, which is the whole circle, you are removing this common area. So when we are removing this common area, this I can draw it with another color. So if we are removing this common area, we will get the set A minus B. Okay. In this case, when we want to get the set A minus B, so the set A is this big circle, and from this set A, we are removing the elements of B. So this inside B will be removed. So this will be the region which is A minus B. Okay. This region outside this circle B. Now we'll see what is A intersection B in all the 3 cases. Let me change color. So A intersection B. Okay. So in the first case, there is no element which is common in both A and B. So there is no intersection. In this case, A intersection B is empty set. Okay. In the first case. Now in the second case, this region is common to both A and B. So this is actually the A intersection B region, because this region is common to both the set A and B, and intersection is the operation which gives the common region between the set A and B. Okay, so this is the common region. What will happen in this, the third case? Set A is the bigger circle, set B is the smaller circle. So what is common between the set A and set B? The set B itself, right? Because whatever the element in the set B is, it is an element of set A. So this region is common between the set A and set B. So it will be the intersection, A intersection B. Okay. Now we have to see what is A minus B. in all the three cases. So I'll again change color. So let me take blue color. So in this case, in the first case, we have the set B and we'll subtract the set A. So there is no common element between A and B. So this region will be B minus A. In this case, this circle, this side, this circle is the set B, right? And if we remove the elements of A and B which are common, which is this part, so we'll only get this region. Right? This is the set B minus A. Now in the third case, we have element B, sorry, set B, and we have to remove the element A. So you see B is inside A. And when you remove the element A, there is no element in B remaining. So in this case, B minus A will be an empty set. Okay. Will be an empty set. Just 1 minute. B minus A will be an empty set. Now, this note is saying that these three sets, A minus B, A intersection B, and B minus A are mutually disjoint. And what does mutually disjoint says? It says that there is no common element between these three sets, A minus B, A intersection B, and B minus A. You see, this is the set A minus B. This is the set B minus A, and there is no element in A intersection B. And you see, there is no overlap between these three sets. So they are mutually disjoint in this example. In this case, you can divide it like this. So this is the set A. The common area is A. This is the set A minus B, this region, this one. Let me draw it more clearly. So here, this part, I'll draw separately, okay? This part. So I'm drawing this part separately. What is this set? This is A minus B. Now this inside part, I'll draw again separately, which will be like this. So this is A intersection B. And the remaining part, this will be B minus A. So you see, these three sets, they have nothing in common. This set, and this set, they are disjoint. Okay. In the third case also, the outer circle minus the inner circle, which is A minus B, this red region is one set. This purple region is another set, and A minus B is an empty set. So all the three sets are disjoint. There is no element common between these three sets. So all the operations we have seen which we can perform in sets. We will do few examples and then we'll see how these problems are solved. So we have two sets, set A and set B. First we have to do A intersection B. So A intersection B will contain the elements common in both the sets. So if you have these two sets, you see 3 is common, 5 is common, and 7 is common because it is present in both the sets. So the intersection will have 3, 5, and 7. Now if you perform union, so union says it contains all the elements in A as well as in B. So you have to write 3, 2, 3, 5, 7, and 11. So the elements which are present in A as well as which are present in B will be in the union operation. Okay. Now we'll go to the next example. We have a set A and a set B. We have to find A difference B and B difference A, and then we have to perform a union. So we have A difference B, or we can write A minus B. So from this set, we are removing the set B, which is this element, and this element, because it is present in the set B. So we'll only contain 2. Now when we perform B minus A, so in this set, we have to remove the elements of A. So 3 will be removed, 5 will be removed, 7 will be removed because it is present in the set A. Only element remaining is 11. So we'll write 11. Now we have got the set A minus B and B minus A. Remember, A difference B and A minus B are the same. Okay. Now we have to do a union operation between these two sets. So if we perform a union operation, A minus B union B minus A, we have to write the elements in both the sets. So it will have 2 comma 11. So this is the answer for this problem. Now we have a set A which contains prime numbers less than 10. So we will write prime numbers less than 10 are 2, 3, 5, 7. And the set B contains even numbers less than 10. So we will write even numbers less than 10, 2, 4, 6, 8, and 10 will not be there because less than 10 they are saying. And what we have to do, we have to do intersection. So A intersection B. So what is the common element between these two sets? 2 is common in both the sets. So the intersection will give one element which is 2. So A intersection B gives this set. Okay. So this is all the problems I have kept here, and therefore we complete this lecture. So what we have covered? We have covered Venn diagram, what are the operations we perform in sets, and we saw some practice problems. I would request you to to practice more problems in this, and if you have doubt, you can ask anytime. Thank you.